On today's episode of Pipeline Things, do you slipstick it or do you slapstick it?
Or dipstick
Wasn't that a
it.
game? Dipstick. I don't think we'll go with that. On all seriousness, this is a great episode, one that gets me really excited. If you're into geohazards, if you've ever had questions about responses, maybe what inclinometers look like, this is honestly a really good episode. Mr. Rhett Dugan from Pillar IoT joins us, and we talk about some of the challenges as well as the really good things you can get from inclinometers, and then maybe where the future of inclinometers are moving. Highly recommend this episode to all of my geohazard nerds out there, and hope you enjoy it. Thanks for joining us. Boom. All right. Welcome to today's edition of Pipeline Things. For those of you who aren't on the webcast or the is it YouTube? Yeah, YouTube. You didn't get to see the rolling in intro that Chris and I had, which was pretty amazing and different. Always looking for new, fresh things to do. But really excited to be with you guys on today's episode of Pipeline Things. I am your host, Rhett Dotson, my co-host, Christopher DeLeon. Chris, do you ever feel rushed?
That is
It's your whole life?
I'm married, 4 children, and I work with you. I'm always rushed.
I was not trying to drag Amanda or your life business partner into the conversation. What I was trying to do is say that, sometimes I feel like we are in control of this podcast, and sometimes I'm not sure. Sometimes I feel like it's Miss Producer's podcast because she was honest today. Like, you have to get started with this episode. You have to film it.
Have
I'm
you
like,
noticed that she's definitely getting more into
controlling?
authority?
Is that the wrong word?
Oh, come on. Authority, right? And I love it. Yeah, you want people to take ownership of things.
For sure. I mean, granted, viewers have gone up and quality has gone up and all these things, marked improvements, but it's also come with a loss of control. So
Yeah, but I think that's okay.
yeah, it's okay.
We trust her.
Yeah, we do. We'll keep her. Way to go. So, but since we are on a rush, I now feel like we must move on to the podcast. So for our listeners that are coming on today, it's going to be another hot topic. And by hot topic, I mean we're covering geohazards and things associated with geohazards. And so I want to go ahead and introduce our guest, but I also want to encourage, I get questions about what we're going to talk about a lot today, which is why I get excited about this episode. So when Christopher and I bring these episodes out, one of the objectives we have is to disseminate information and learning in the industry. I think this is a good episode from a learning perspective, both about an existing technology and maybe where a technology is moving in the future, which is really cool. So with that in mind, I'm going to bring on Rhett Dugan of Pillar IoT. Rhett, are you on screen now and can you hear us?
I can.
All right. Well, welcome. Thanks for joining us today.
Thanks, guys.
Hey, Rhett, do you feel rushed? I just have to know. Did Miss Producer Trip S, did she take care of you, or do you feel rushed as you came onto the show?
She took great care of me, but I always feel rushed anyway.
It's probably just game time pressure. It might not be this feeling of rush, right? It's pressures of privilege. Yeah. Isn't that kind of the idea?
Yeah. Well, it's okay. If you have any complaints about the show, you can fill out the form afterwards. Not against Christopher or I, obviously, because nobody would ever have that. But we like to take care of our guests for sure. Rhett, tell us a little bit about yourself, buddy. The audience needs to move on now. They're like, Rhett, get with the picture. Who are you, Rhett? Tell us a little about where'd you come from?
Yeah, absolutely. So I've been in the IoT pipeline industry and other critical infrastructure industries for about 4 years. Prior to that, I was an electrical engineer in the aerospace titanium industry. And so, came to Pillar Innovations and have been working in developing new products as well as our service entity and using our expertise to get these products out into pipeline industries, to rail industries, to power generation industries. And it's been a fun ride.
Yeah, so that's a good thing. I want to spend just a second there, right? Because I think within the pipeline space, Pillar IoT is certainly not a name that people can go, oh yeah, 20 years ago, right? I've been working with Pillar IoT, but you guys are multifaceted, right? It's not just pipeline. Pipeline is one space and a much broader portfolio that you guys work in. So if you don't mind, catch the audience up a little bit too. Pillar IoT, what are you guys known for?
Yeah, absolutely. So originally, Pillar Innovations, kind of were situated in central Appalachia here, and we've been a mining technology provider. And so we're right in the heart of coal, and have been providing solutions to mines. We're one of the first companies to show mining operators that they can put fiber optics for communications underground, and have kind of pioneered a lot of initiatives both to make them more efficient and more safe um, over the years. And just because of the shift in energy demand, we kind of diversified in the early 2000s into other industries, and so happened to be perfectly located within the shale gas boom. And so we're easily able to adapt and start to enter that pipeline market, as well as some of the gas development markets as well.
Hmm. All right. And so we always like to ask people this: how'd you find yourself in pipelines? We know for certain you did not come out of school and apply for a midstream job, because I don't think anyone does
And
that.
we're hoping it wasn't after a long night at a bar. So
True.
fill the gap for us.
Yeah, so I think it was kind of that time period that I was just referencing, where the company was really trying to figure out how do we get a foothold in the oil and gas industry, and just kind of were at a meeting with a customer and asked them what their biggest problem was, and they started to tell a story about how they had a pipeline that was over top of a longwall coal mine that was actively being mined. And so that pipeline was expected to subside about 6 feet in the space of a couple weeks. Pretty big hazard for them. And they told us that they were sending operations technicians to this about mile-long project so that they could walk the job every day and plug into individual strain gauge readings, record them, and then come back to the shop, upload those so the engineers could then do some calculations and determine how much stress they had at these stress concentration points on their pipeline. And so that customer told our sales representative that if we had a solution to automate that process where we could get data to the cloud, he'd buy that right now. Yeah, so it was right up our alley. We'd already implemented solutions like this with battery powered wireless technology for the coal mine operators, and we kind of quickly went back to the drawing board, put our R&D engineering team on it, and had a solution in about a month where we were solving that problem in the pipeline industry for that customer, and we just sort of organically gained a lot of traction. Where once we had developed this simplistic solution for a problem that was prolific in our area, the solution kind of sold itself, and we just started to understand more about pipelines and about geohazards and some of the challenges that they're posing, and thought that we could continue to help that industry by developing other targeted solutions based on the pain points that operators are having in these regions.
Cool. So for our audience out there, just to sum it up, you guys got your foray in strain gauge and wireless transmission, or your footing, I should say, and into strain gauges on pipelines, basically addressing the longwall mining threat, if you will. Cool. So for our audience, just so the audience knows, that's not what we're here to talk to you guys about. That's not what I'm most excited about. I think strain gauges are cool, but I think they're actually pretty, I don't know, ubiquitous. I feel like I need a word to compete with prolific, because he used prolific, and I was like, man, that's a good word. So ubiquitous, I will use that. Fairly ubiquitous in our industry. But Brett, that's not the solution we wanted to chat with you today. I want to go talk a little bit about inclinometers, because that's an area that you guys are working on, I think, making some kind of unique advances about. So I'm going to shift the focus there, and tell me a little bit about what your experiences, if you don't mind, and Pillars experiences with inclinometers have been.
Yeah, so with having that strain gauge solution, that was kind of extensible into the landslide monitoring market, and so the same customers that were having mine subsidence events started asking us to help them monitor landslides. And with that came strain gauges when they were pertinent, but that requires a pipeline to be excavated, and there's some challenges there, and it's not always the best solution. So our operators also asked us if we could help them provide telemetry for in-place inclinometers so that they would have that same level of data that they were used to seeing from our system only instead of telling about pipeline health and the stress that they're seeing on their pipelines, start to understand that soil movement. So we started some projects with various operators in their landslides to help them install inclinometers. And that requires a few things that were a little bit outside of our purview, but we assisted with them anyway. And those are, drilling these installations in. This device requires that it's installed in a casing. There are little wheels on the inclinometer, and there's a tilt sensor, and those wheels engage in that casing, and as the soil moves, they tilt more and tell you direction and magnitude of movement at depth. And that casing installation requires that you have this drill rig in place. It's kind of a challenge to get the casing down, get it anchored correctly, get it in the right spot, make sure that you're going through that failure plane of that landslide. There are a lot of just difficulties that make this process.
You mentioned a lot of things there. I want the only reason I want to pause on this, Brett, is I get this question a lot, right? So full disclosure, because I know Miss Producer is very, very concerned. I have never actually installed an inclinometer. But I get asked, usually because I'm the first point of recognition or the first point of contact when we're dealing with an active threat with clients, and they're like, there's not, I think, a lot of organic understanding for people who have installed inclinometers. They got it. Yeah, I mean, but its very name tells you how it works. It's going to tell you something about how the ground is inclining or the slope is moving. But there isn't always an appreciation for the challenges that go with installation, right? And so you hit on a few of those, and I just want to bring them to light, right? So if you're listening to us on this podcast right now, and you're like, hey, maybe you've been thinking about inclinometers, maybe you've seen them in the PHMSA bulletins that are out there as well. I think a lot of people think you walk out there maybe with like a sledgehammer and you drive a pole in the ground, and that's, I mean, because that's what's like inclinometer, right? I mean, boom, drive a wedge in the ground, it'll incline. But these devices are both more sophisticated and a bit more challenging than that. So a lot of times when they engage, like you described a drilling rig, right? But put that into context. What type of rig are we talking about? Is this bigger or smaller than an F-250?
Yeah, so probably about similar size. I think there's all different flavors, right? But the ones that I've seen, they have tank tracks, and they're able to handle steep slopes and right-of-ways and things like that. And they have this mast that tilts up, and they drill these various sections down and get through that material that's potentially moving and then down into the competent material, where then they can provide a pathway to anchor the base of this inclinometer strand, so that that at least your reference point is fixed, right?
Right. But so one of the things I want to bring on is it's a bigger piece of equipment than I think a lot of people are expecting. Because you can do a first pass foray, what we call a level 1 geohazard analysis. And we talked a lot with Alex McKenzie Johnson about that and Geosyntec. Those guys will go out there oftentimes and characterize a landslide with nothing more than maybe a hand shovel, right? And that's easy for an operator to implement. When you get to the point as an operator where you're thinking about doing this, it's not as simple as sending Chris out there with a hand shovel to sample the ground, right? We've got a piece of moving equipment now on the pipeline. For a lot of operators, that now means, we have to get into permitting, right? Which becomes a significant challenge. The access would be, let's maybe say no different, maybe better than an excavator if you're doing that. But again, depending on the location of the right-of-way, access to the right-of-way, even the ability to get the drilling unit in there can present some challenges. And so I've seen this play out a number of times. We're just getting the ability to put it in there is a challenge to get the instrumentation installed. And then you mentioned some other things. Go ahead.
Yeah, that ends up being a project in of itself, right? Is figuring out how are we going to get this drill rig to site. We've got, like you mentioned, permitting. There are safety permits that are going to be required because you're working on steep slopes on uneven terrain, right? That might be unstable, and you have to deal with landowner access, and oftentimes this takes weeks, sometimes months, for an operator to execute, and can cost in excess of $100,000 before they even consider purchasing instrumentation.
Yeah. Man, I really appreciate you putting a scope on that, because I think that that's extremely helpful for operators. Now, despite that, I want to say inclinometers give us good value, right? And whenever they're properly utilized, properly placed, they give excellent information about the depth of the landslide, the degree to which it's moving, and how surface might be differing from at depth. And again, I think that's something that's fairly intuitive to our audience in terms of the usefulness, right? So to give catch the audience up, that's extremely helpful from a standpoint of, if a lot of times we see surface-based movement, but if we're not moving at or below the depth of the pipeline, we potentially don't care about it, right? So the first and easiest response for a lot of operators is, hey, I'm going to put surface-based monuments out there. I can get them in days rather than potentially the weeks or even the month that you just described, Brett. But the problem is we get 18 inches of movement at the surface, and now we're trying to ask ourselves, well, are we engaging the pipe? Do we know if we're engaging the pipe? What level is this happening at? And that's where, again, when properly installed, inclinometers can do a good job. So do you agree with that?
That's a great point. In Appalachia, we, especially just due to the geologic features in the area, have a lot of really shallow landslides. And the difference between a landslide that's 3 feet deep on its failure plane and one that's 8 feet deep when your pipeline has 5 or 6 feet of cover is huge. Like you mentioned, it could be something where we just want to make sure that we don't have any sediments to spill into a nearby stream, or it could be something that's actively putting stress on our pipeline.
Fantastic. So, okay, audience, hang on. This is where we're going to take a break, and I'm going to plant the seeds for when you guys come back. We're going to get into what Pillar is doing differently, or a solution that they're putting out there that might make it a bit easier than a track hoe and $100,000 per installation, and where you might fit in the industry in terms of what we're looking for and what they're looking for and how it could change things moving forward. But in order to get all that, you're going to have to hang on with us. We will be right back after the break.
So that's your Traeger app?
Yes.
And it's pulled pork?
Yes.
And you
Pulled
made
pork.
6 pounds so we can come over?
You absolutely can come over. Brett, invitation extends to you
lights
too.
on. Are we recording? The lights on.
Oh, well, for our audience, welcome back. So I want to pick back up with the audience as we get into this, and I want to talk about where we've been, right? So let's start with the threat of geohazards and landslides, audience. And again, many of you that are listening have been on the call with me where we've discussed this. I've got an active landslide. I didn't know it was there. We know it's initiating, or we suspect that it is interacting with the pipeline, and I need to respond. You got a couple of solutions on the table. All have their pros and cons. You don't want to excavate the pipeline or have to dig it up, so you feel like strain gauges are off the table. Inclinometers seem like an attractive alternative to that. They won't measure the pipeline's response. They'll measure the soil response. That's great. You're like thinking, oh, I should be able to get an inclinometer in there, right? I mean, you get a shovel.
Try a pigging solution.
Yeah, absolutely.
Put some IMU on it.
So we can do the IMU. Problem is, you might have costs. You might have IMU lead times on that if we're talking conventionals and not something that's mounted in a cleaning pig. So a lot of times operators, even if they do all those, they go to inclinometers. And the problem is, as we've already established, inclinometers have, unfortunately, complications, right? Unless your pipeline's like right on the road and you can pull off of the road, you're usually talking about getting a tracked drill rig in there to install it, which has cost, it has planning associated with it. And it often requires permits, which depending on where your pipeline's located can really be, to be honest, the killer. You could be looking at weeks, months, maybe even years potentially to get the permits you need to get the pipeline, to get these inclinometers installed.
And again, not that we're trying to say that that's a negative. It's just,
it
reality. Has its challenges. It has its project constraints that need to be dealt with. And sometimes that can be a bit overbearing, and it makes you want to pick your head up from the grinder and say, what else can I do?
But you still want the information, right?
Yeah.
And you want the information. The pros about inclinometers, Chris, is we get real-time information, which is good if they're installed, with a thing that connects directly into the internet. The other thing that we get, so that gives us information on the depth the landslide's moving and the rate at which the landslide is moving, right? Those are both extremely helpful from an FFS and a management standpoint. So it's not that like, oh, they're bad. It's that they're not as easy to get installed as people, I think, initially think. And Brett, that's where you come back onto the scene. So what I'd like to do is tell us what you guys are doing that's a little bit different. Let the audience in on the secret.
Yeah,
Because it's
absolutely.
public now, right? This isn't the first time we've let it out.
So I think you were kind of
It is
before the
public.
break, you were being a little tongue in cheek when you were saying it's not something you just hit it with a hammer and you slam it into the ground and get information out of that process. Well, Pillar asked, why not? Right? Why can't we drive these into the ground? Why can't we use similar sensing principles, but with a much easier installation method? And so, especially in these shallow landslides, operators are already using some.
I'm sorry, stop. Define shallow. Which shallow? Because that's subjective. I'm thinking like 2 to 3 feet, but you might be thinking something different. Which shallow to you?
To me, shallow is less than 20 feet. I think that there's
Oh, okay, that's a lot deeper than I was thinking.
Yeah.
Okay, so shallow is defined as 20 feet. Pick up, Brett. I'm sorry. I really needed to clarify that.
Yeah, no, I mean that's a point of contention within the geology world. So that's good that you stopped there. You may have opened a can of worms a little bit with your viewers, but yeah. So operators are already using some technologies to get information about soil. One of which is called a DCP, which is a dynamic cone penetrometer. And you basically take a known force, which turns out to be about a 30-pound slide hammer, with a known point cross section, and you drive that into the ground, and you determine how many blows per length it takes to drive this in, and you can infer certain soil properties that are going to give you information that you might need to fix this. Well, it just turns out that that instrument has an ID of about 9/16. So my team set out to say, let's make an inclinometer-like device that slides within this DCP so that we can just drive it in the ground with a manual slide hammer and slide our instrumentation into the DCP, deploy an anchor, and jack the DCP out, and we're good to go. We're giving information that's inclinometer grade and actually has a little bit higher resolution than in-place inclinometers. Our device is about 6 inches in length, so you can get really granular with that failure plane depth versus having to infer that with some larger distances between sensors.
So wait, I'm going to stop you because I got distracted by, I think I want to say the beautiful simplicity of taking advantage of something that operators might already be doing on the pipeline, which is the standard cone penetrometer test, right? And again, a lot of our audience, Chris, are you familiar with the SCPT test?
Yep, I'm not.
Trip S, are you familiar with the SCP test? You haven't used one when you buy a new house in the backyard or anything like that? Yeah, it's pretty uncommon, right? So I feel like we need to explain it because that was actually pretty clever. And I've talked to you about this before and didn't know that's what you guys were doing. And so I was like, oh, that's freaking clever. So to catch the audience up, when you want to take soil properties, Chris, a lot of times we're talking about actually capturing a portion, or we'll actually drill a core out of the soil, take that sample, send it into the lab, find out things like its liquid limit, plasticity limit, its makeup, blah, 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 so on and so forth. But there are more simplified methods, which you could think about, kind of similar to automatic ball indentation on steel, where basically we're just going to put a calibrated instrument and drive it into the ground and count the number of times it takes us to drive it a certain distance, for layman's terms. And obviously when you do that, it leaves a hole in the ground, right? And it sounds like you guys are just taking advantage of the hole that's left in the ground to then insert your instrumentation.
Yeah, exactly. And it provides just a conduit for us to get the instrumentation to the depth that we need. And, our goal is that the slowest part of this process is making that 811 call, waiting 2 days for that to clear. Then we just head out with a backpack full of DCP tooling and some sensors, and we start to get real-time data into our operators' hands.
So what does this thing look like? I mean, what are you dropping into the hole? You mentioned it's 9/16, 7 inch long. What does it look like?
You said your sensor is about 6 inches in length.
Yeah.
So you're dropping a 6-inch tube that's 9/16 of an inch in diameter? No.
Yeah. So we actually make little individual segments, and they have an M8 connector.
So you're holding up your pin for the people that aren't on
Yeah.
If you're not on the YouTube, he's holding up his pen like this, right?
Yeah, this is a mocked up slipstick segment. It's not a pen. That's the
Oh.
sensor. So we're 1/2 inch diameter by 6 inches long. We have a custom circuit board in here that has a digital bus on it, so we can communicate with some sensors within this footprint. And then there's connectors on each end, and there's a flexible portion so that we can have up to a 30-degree bend and measure at least a 3-inch movement per segment.
So I got to stop. I need to describe what I'm seeing on the screen to the audience. So Brett is holding up an object that's about 6 inches long and looks like a really nice fountain pen. But one end has about 1.5 inches that's flexible, almost like, the cabling for a speaker mic, because I'm looking at that's what's right in front of me, right? Or an HDMI cable. Like it's just that flexible on the end. And then the other 4 to 5 inches is kind of rigid, if you will. And so that rigid portion is housing the circuit board. And then the end is the kind of the flexible part, I'm going to assume, without getting into details, that's measuring the inclinometer. So what y'all do is we've got the hole from the standard column penetrometer. You're just dropping that in the hole, and I assume you can drop multiple. These can be strung up. Like if you want 4 or 5 or 6, you just string them up right back to back and drop them into the hole.
Yeah, exactly. So if you drive your penetrometer in 18 or 9 feet, then you just connect 18 of these sensors together with an anchor on the end, and you slide that down that instrumentation, line it up with the downslope direction, and then you jack your DCP out, and you've got that data.
I'm sorry, that's clever. I just want the use of the hole from the DCP is what's got me. I'm like, that's clever. So the only real limitation I see potentially, Brett, is if you reach refusal on the DCP, then you wouldn't be able to use this technology, right? So refusal is when you can't. It's like driving a stake in the ground. Yeah, you can't drive it in. You wouldn't be able to use this.
Yeah, I think that will be the part of the process that'll slow this down a little bit, where, if you have some soils that have boulders or cobbles or things like that, those might be less prone to this sort of technology, or you might have to try a couple times in different locations before you're able to achieve the depth that you think you need to be able to monitor that full column of soil.
So two applications questions. One, how much homework does an operator need to go through before they can choose to use this technology? And then the second one is, how close to the pipe do you need to be?
Yeah, so the second one's a little bit easier to explain. That's operator dependent, right? Whatever their regulations are, if they're comfortable with us being within several feet, that's fine. We just need to mark that utility very well so we know that we're the specified distance off of it, because obviously we want to put these as close to the pipe as we can for 2 reasons. One, you want to know the movement of the landslide close to the pipe because that's the asset we're concerned with. That's obvious, right? Well, the second reason is assuming that operator followed best practices with backfilling their pipeline, it's going to be a much easier spot for us to drive deeper, because they should have screened those soils when they're backfilling their pipeline. So that first 6, 7, 8 feet should be rock free. We should be able to drive pretty easily through those portions. So we do try and get as close as the operator will let us to the pipeline. In terms of how much homework is required, the installation is pretty simple from our perspective. You tell us where you want to put it, or if you want someone else to install it, we'll just ship you them. But it really does make sense to, if you don't have geotechnical engineering experience, to get someone with that expertise to develop a monitoring plan where you say, okay, I want, sensors, 4 sensors on the top of this pipe and then 2 by this PI, or however that works, right? To have that cohesive plan and to reach out and make sure that, someone that knows soil mechanics and how they'd be moving in these situations is driving where this instrumentation is put.
Help us visualize a little bit the kind of the position of the sensors relative to the pipe, right? So, if I'm thinking I have these connected in series vertically, do you want to cover a significant portion of it, kind of at the same plane as the pipe and some beneath the pipe, so you're kind of getting like this full motion picture of how the soil's moving? Or, or normally you guys targeting a certain zone of it? Obviously, you're coming in from the top, so you're getting the top side of it. But help us visualize that a little bit with some words.
Yeah, so our goal would be to drive our bottom segment into competent material, to get below that failure plane so that we have an anchor point. Usually
Yep.
refusal means that you're starting to get into some material like a shallow bedrock that's likely not sliding. So that's usually our target. But yeah, we do need to be below the pipeline so that you can obviously it's a differential measurement, right? If you don't get below the pipeline, you could
Sure.
just not see any movement because that entire mass is sliding cohesively. So you really
Yep.
need to get into a good anchor spot so that you can see those differences. Now, on the top of the segment of the strand, we're going to have a geodetic reference point so that you can verify that you are in competent material. Say you see no movement and you're kind of concerned by that because it's kind of clear from your phase one analysis that this slide is active. Then maybe you didn't get deep enough. Maybe you're not anchored correctly. So you can come back out and you can shoot the top of the instrument and understand. Oh yeah, this entire sensor strand is moving, and that kind of answers your question, right? As long as you're deeper in the pipeline, you know that you're impacted, and that's all kind of moving cohesively.
And wait, I just want to make sure too we cover this for the audience because I think it's clear, but just to make sure there's no confusion, instrumentation outside of this would be the same as what you would have on an inclinometer setup, right? So outside of the measurement device that you're leaving in the hole from the standard cone test, everything else is the same, right? Communications, logging the data, whatever, all that's no different. There's nothing specialized here in terms of that.
Pretty much, yeah. Some
I mean,
nuances.
so that's what I wanted to maybe again continue to frame the picture a little bit on, right? So you said you have a digital bus for communication. There has to be some power here. Just walk us through pretty quickly what that rig up looks like.
Yeah, absolutely. So got a couple different options right now. The operator that we've been working with on this effort almost exclusively has a requirement that we are completely at grade with our installation. So we house all that in what we call a vault, where we have an upstream translator and battery power and logging capabilities so that we can read that data bus, store that information, and then have enough batteries to, I believe our requirement's 1 year battery life. And so that's option number one. We also, within that vault, have a at grade antenna option, and that's actually pretty difficult to do. If you look at cell towers, any sort of antenna, we try to get pretty high above ground because our distance or transmission distance is limited. We found an antenna that we can get several hundred feet of data transmission with it. So if we want telemetry rather than logging, we can use a meshing Wi-Fi network that Pillar's been using in all of its products and is pretty common in the industry to get that information back to a repeater that then has cloud access. So that data transmission aspect of things is pretty standard, but will be sufficient in these cases.
All right. So I want to use the remaining time that we have to help the audience answer a couple of questions. And one is technology-wise, and I don't want to refer to actual technology readiness levels. And you're not, just so the audience knows, Brett's not a sales guy, he's an engineer, which means you're going to get a more honest response. Where are you guys at in the development cycle on this?
Yeah, so we've done some prototype testing where we've did some forced translational movements of soil with prototypes and have compared that against inclinometer accuracies and precision. And we're really, really excited with that response. We could tell exactly where that landslide's failure plane was, and we were more accurate with our instrumentation than we were with the truthing instrumentation that we were using. So we are expecting our first batch of first article units later this week. And we have a packed Q1 of 2025 with an operator where we're going to be installing about 15 sites worth of what we call slipsticks, this inclinometer solution, according to their instrumentation plan. And so in Q1, we're really going to be putting this through the test. We're going to be understanding just how effective we are with our installation method. We're going to be verifying that this, our accuracies are that sub 10th inch that we're looking for, which is similar to inclinometer grade. and also, looking for any bugs or any problems that we might have where we might need to iterate on that.
Gotcha. So this isn't, I want to put it fairly. This isn't a quote unquote market ready solution. Like it's off the shelf. You're ready. You know exactly what the details are. The bugs are worked out. You guys are fully in field deployment stages. You're beyond prototyping and things like that. You're now into, let's just say your first rigorous field test in Q1 is what that'll be. And we always learn things in that. But again, I think one of the nice things about this is it's a little more limited because you know the problems on the data acquisition systems, the fiber mesh network. That stuff's easy because you've been doing that for a long time. This will primarily be around the units in the whole, which I like.
And also validation for some form of performance specification.
Yep.
Right.
Excellent.
If you guys are targeting that 1/10 inch, you're going to start having plenty of data to understand what that begins to look like.
So what are you looking for, Brett? Like for our audience out there, if there's somebody who's thinking that, hey man, I've got a site where maybe I would like some inclinometers, or maybe what in Q1, Q2, let's just say in maybe the rest of 2025, what are you guys looking for to help advance this technology? What types of sites, what types of data, opportunities? What should an operator expect if they decided to actually email you after this podcast?
Yeah, absolutely. So we're looking for an operator that's sort of innovation minded, where they would love to be a part of this process and provide feedback, so that we can have more than one voice. So it's great that we are working closely with an operator, but to get a couple more into that queue would be awesome. Just because we'll learn other people's procedures and challenges or nuances that they might have, and so really, if that you kind of check that box, what we also need is pipelines in this Appalachian area where they are prone to shallow landslides, predominantly or preferably close to West Virginia, where we can kind of quickly get back and forth to a site if we notice any problems. And, if you want some data about your site, or even if you already have inclinometers installed and you want to start truthing this technology because that's already part of your integrity management plan, but you see the pain points and you want to improve upon that, that would be optimal, right? Because then we can really benchmark this in comparison to technologies that are already accepted by the industry. So,
So West Virginia is kind of the epicenter, but we can go outside of West Virginia. So like
absolutely,
Ohio,
it just
Virginia, New York
has really shallow slip clays that lend itself to this technology. And that, you're right, that extends into Ohio and Kentucky and those areas as well.
All right. Man, Brett, I gotta be honest, this has been super helpful.
Yeah.
So for our audience out there, the genesis of this episode was I actually ran into Brett and this technology quite some time ago. And I just want to close with, I was excited about it because I saw a lot of potential to help operators. And I'm hoping that you guys, our audience out there, hears that because, again, I do get a lot of questions about inclinometers and I do come across a lot of landslides. And this seems to be a pretty novel technique for cost savings that could give us real-time data and maybe be kind of a marked change or improvement from an existing technology. So I'm excited about it. Brett, I'm looking forward to seeing how it rolls out. And hopefully, man, we end up having you on in, I don't know, maybe the end of 2025, and you can tell us about how some of those field trials went.
Yeah.
So
that would be great.
The audience might want to bank on it now. That means if they don't see you, they might be like, oh man, what happened to that? This guy's going back on. So, well, Chris, you got anything you want to close with, buddy?
No, we appreciate you, and keep us posted.
Yeah,
absolutely. To our audience out there, thank you for joining us on this little mini series. Wish to thank Brett and Pillar IoT for joining us. Look forward to what you guys bring in 2025. To our audience, that's going to be a wrap for this episode of Pipeline Things. I am your host, Rhett, my co-host, Christopher DeLeon, and we'll see you again in the future.
Thank you, guys.
Pipeline Things wishes to recognize Mr. Brett Dugan and Pillar IoT for the support of this episode, Mr. Sarah Etier for her executive producer role, and also to the Work Lodge for facilitating the environment with which we recorded. Thanks, and see you in 2 weeks.